Hey guys, welcome back to my channel. In the previous video, we finished exercise 13a, chapter Indefinite Integral-1 of OP Malhotra's textbook for ISC Mathematics. Today we'll be starting off with exercise 13b and we'll be doing the first 5 questions. So let's begin. So the first question is integral of x squared minus 1 the whole square by x cube dx. So first of all, I'll be expanding the numerator. This is a minus b the whole square, which is a square plus b square minus 2ab. So x raised to 4 plus 1 minus 2 into x square upon x cube. Now to integrate this, I can just write this fraction as 3 separate terms, which is integral of x raised to 4 by x cube plus integral of 1 by x cube minus 2 is a constant, so I'm taking 2 outside, integral of x square by x cube. Okay, so now this gets cut when we're left with x. This we can write it as x raised to minus 3. We can take this in the numerator, and this becomes 1 by x. So the integral of x, as we know, x raised to n plus 1 upon n plus 1. So this becomes x square by 2. N here is 1 because n is the power of this x raised to 1. So the integral would be x raised to 1 plus 1 upon 1 plus 1 like we did in the previous video, plus integral of x raised to minus 3, and we're going to apply this same thing here, minus 2, and we know that the differentiation of log x is 1 by x. So the integration of 1 by x is log x. You can also write it as log to the base ex plus c. So let's integrate this. X squared by 2 plus x raised to minus 3 plus 1 upon minus 3 plus 1 minus 2 log x plus c. X squared by 2 plus this will become x raised to minus 2, so we can take that in the denominator and write it as x square, and this becomes minus 3 plus 1 is 2, and minus sign goes here, so x square by 2 minus 1 by 2 x square minus 2 log x plus c. This is the final answer. Guys, so the next question is integral of x plus 1 by x square minus 1, and we know that this thing is it's a square minus b square, which can be written in the form of a plus b, a minus b. So this becomes x plus 1 into x minus 1, because this thing when multiplied gives me x square minus 1. So I just wrote it in a simplified form, and now we can see that we can cut the numerator and a part of the denominator. This whole thing gets cut and we are left with 1 upon x minus 1. And we know that the differentiation of log x minus 1 would be 1 upon x minus 1. So the final answer is log, you can write to the base e and into mod x minus 1, because in integration we need to write the mod of log, plus c. Okay guys, the third question is the integration of e raised to minus x. Now we know that the differentiation of e raised to x is e raised to x itself. So the integration of e raised to x is e raised to x itself. But here we have e raised to minus x. So we can just write this as e raised to x into minus 1. So we can see that minus 1 is the coefficient of x, which is why the integration would just be e raised to x into the coefficient of x, which is minus 1. And we know that when we differentiate this, we get e raised to minus x itself. Don't forget to write minus here, because the differentiation is the same as the integration. All we need to do is multiply it with the coefficient of x, so that when we differentiate this, we would have e raised to minus x into minus 1 into this minus sign. So ultimately we would have e raised to minus x. Now don't forget to add plus c in the answer, and we're left with this, which is the final answer. So let's move on to the fourth question. which is the integration of e raised to 3x. Now we have to apply this similar thing here. Over here, like I said here, I said multiplication by mistake. I meant that we are supposed to add -1, which is the coefficient of x, in the denominator. So because we have e raised to minus x upon -1, it ultimately becomes minus e into raised to minus x. Minus e raised to minus x. So sorry. So now we have e raised to 3x here. So we're going to do the same thing, e raised to 3x and the coefficient of x in the denominator plus c. Because when we differentiate this, we would have 3 into e raised to 3x upon 3. The 3 and 3 will get cancelled, the c will turn into 0, and we will be left with this, which is why integrating this, we have this as the final answer. So moving on to the fifth question. The fifth question is integral of a raised to 2x dx. Differentiation of a raised to x is a raised to x log a. Integration of a raised to x is a raised to x upon log a, so that the log and log will get cancelled. Because if we are only left with a raised to x, it means that the log has to get cancelled somewhere, which is why the integration of a raised to x is a raised to x by log a. Because when we differentiate this term, we would have a raised to x into log a upon log a, and we would ultimately be left with a raised to x. That's why this is the integration. Now the integration of a raised to 2x would be a raised to 2x upon log a into the coefficient of x, because we normally put the coefficient of x in the denominator. So the final answer is a raised to 2x upon 2 log a plus c. So that's it for today, guys. Be sure to comment down below if I'm going too fast or if I'm not clear. I'll definitely work on that. In the next video, we'll continue with the next 5 questions, that is up to question number 10 of exercise 13b. So see you in the next video, guys. Bye. Thank you so much for watching.